Alright, so because it was a simple one, I reckon you guys might already have an answer for it. Cos x equals minus 1. Have a think in your head of what cos x looks like, right? Okay, I keep encouraging you to go towards, even if it's just a simple one, a graphical means of solving things because it will rescue you from a lot of problems when you've got your graph in your head. So where's the first time that it's equal to minus 1? What value in radius? Pi. Okay. Someone said there. Find x. There it is. Okay. So therefore, right, my general solution, like you already noticed, is 2n pi plus or minus this theta, right? So there's my pi, okay? Now, this is kind of interesting because since I have pi in both of these, I could factorize, right? So you take that pi out and you get this, okay? Now, very, very roughly, sketching out a table for this, okay? Let's test out, let's generate our values here. For n equals 0, 1, 2, 3. What happens? Well, I've got this and this. I'm just going to be a bit cheap and fast because I just want to illustrate a point. When you go for these values, okay, what's going to happen for your first one? It's going to be 0 minus 1 inside the brackets, right? So I'm going to get minus pi, yes? And then this one I'm just going to get plus pi. So far so good. You go to the next one over and you're like, this is 2 minus 1, which is 1. So this is pi. And this will be 3 pi. Okay? And then this one will be 3 pi and this one will be 5 pi. So you can see what a carefully chosen subheading, okay, that these two solutions overlap, right? So therefore, even though this is a correct general solution, okay, you actually don't need to write both of them. You don't need to write plus or minus, because if you just say 1, you'll have all the answers in the other column, okay? So for instance, I might just say that's 2n plus 1. Now that's a bit weird, because these two equals lines, they're kind of not really equal, right? In that plus or minus and plus are not the same thing. But for our purposes, for general solution, they are equivalent, okay? They'll generate the same set of solutions. Now that's kind of trivial. Like, I mean, it doesn't matter which way you go, but you start to run up against different kinds of questions. For instance, you'll get this question, right, in the textbook, and you arrive at this answer, and you check it, and it's all fine. You pop it back into your original equation, and it's all good. And then you look at the textbook, and the answers that are provided to you, and it looks totally different. So how are we going to know whether your answer is right or not? Well, let's have a look at the example. No, sorry. That's a 0. Okay, so here's our second example. Now, tell me, instinct, what's the first thing that you would do to this equation? You've got interesting instincts. We'll get to that instinct in a second. I think the first thing that I would do is I would see it's a product, right? So it's factorized, right? So I can see this as two different parts. I can see it as sine x is equal to 0 and cos x is equal to 0. Okay, just like you were solving a quadratic. Okay, so you've got two different parts, two different factors, so you solve them. Okay, now let's have a look. Each of these has its own general solution, right? General solution for pi is n pi plus switch. Okay, and what's our related angle going to be? It's sine inverse of 0. In the first place, that sine is 0 is at 0. Okay? Alright. Now, by the way, I should note down here that I've introduced this number. Okay, so far so good. Yep.
Do you have to do the plus minus 1 and minus 0, or just write x equals n?
That is an excellent question. And the answer is, yes, you absolutely must write it. Okay? Do you have to write this part? Yes. Yes, you do. Because as a marker, what I'm trying to get is, does this person get what general solution is about, right? Or, as I was just looking at this morning, can you get some right answers but for the wrong reasons, like just by coincidence, okay? And I've been marking some Year 12 papers that are just like that. You've got to be able to demonstrate that you understand. Now, the fact that it contributes nothing to your final answer, because it's times 0, is immaterial. right? I want to see that you know what the general solution is, okay? So yes, indeed. All right, so there's one solution, x equals n pi. So now you deal with this other part over here, okay? What's the general solution for cos?
2n pi.
Okay, now, it is 2n pi, but because I've already used n over here, I'm going to introduce another letter.
2n
Okay.
pi.
So I'm going to call it m, okay? I know usually we go forwards, but O is so easily confused with 0 that I'm going to avoid it, okay? So I'm going to call it m. And then you go plus or minus the related angle, which in this case is pi on 2. Okay? And of course, since I introduced another letter, I better say what it is. Okay?
Yes.
And yeah, that's right. So when you look at that, there's not much you can do with it. That's about it. That's all you can simplify. Okay? Oh, yeah, okay. Yeah. It doesn't really make anything, there's no profound like, oh wow, and I see it so much more clearly now, okay? So I think this is fine. Okay? And here's the interesting thing. This question, at least a variant on it, appears in this exercise that I gave you. And this is not the answer, okay? It gives you quite a different answer. Now, how can we see what the different answer is? We're gonna go to Daniel's first instinct, which is that you can use an identity to make this a bit simpler. Okay, namely, I can convert that using double angle.
Sin 2x on 2.
Yeah, that's right. I'll slap the on 2 out the front. Now, the cool thing about this, there's two really useful things about it. Number one, I'm now solving one general solution, not two. So I've halved my work already. Okay. Secondly, this half out the front, I don't even need to worry about it because I've got 0 on the other side. So it's the same solution as to this. Okay? So that's kind of neat, but something's interesting when we actually go ahead and solve this. Okay? 2x is equal to, now, my equation is going to look very similar to this, right? It's going to be n pi, yes, plus switch to the power of n, and again, I've got 0 here, so it's 0. Okay, so I get 2x equals n pi on its own. And so you divide by 2 and you get this. Now, these answers are different. If I approach it like this, I get this pair of answers. I'll go up here actually. Okay? But if I use a different identity, I get a different answer at the end. Okay. But the thing is, these really are the same answer. I wonder if you can see it. Okay? We're going to generate the values just to prove it. Okay? So with this left-hand side, I've got one way of solving it, 2 ways of solving it, 3 ways of solving it. Okay? So I'm going to draw up my table here. It's going to go n in the first column. Okay? And then over here, I'm going to have my other 3 ways of actually expressing the solution. So I've got n pi, 2m pi, so this is actually m or n, minus pi on 2, and plus. Okay, so let's get some values out, shall we? Let's just do this column because it's super easy, okay? It's going to be 0 lots of pi, 1 lot of pi, 2 lots of pi. So far, so good, okay? What happens in this column here? Well, our first value is actually going to send us into the negatives, okay? But when you go forward 2 pi, you're going to get 3 pi on 2, right? Is that right? Yeah? And you go forward another 2 pi, you're going to get 7 pi on 2. Does that check out? Yeah, I'm adding 4 pi on 2 each time. All right, now we rehearse it with this column. Positive pi on 2, first value. Add another 2 pi. And then add another 2 pi. Okay, so now you can see these are all the solutions we get out of these 2 green branches, as it were. Let's test it out with this one over here. So I'm going to get n and n pi on 2. Keep forgetting. If I forget it, then you probably will forget it. So make a big note that every time you actually write down your general solution, you've got to introduce your number. Okay. All right.
What's the E thing?
element of.
Yeah, so I'll write it out in longhand. That means n is an element of. That's the Weirdo. I think it's actually a capital epsilon. I think. Double check that with your Greek letters. Anyway, the set of integers. That's the funny looking z. Okay. All right. Now let's test out these values. 0, 1, 2, 3, 4, 5, 6, 7. Let's go all the way that far. So when you put in 0, you get 0. You put in 1, you get pi on 2. You put in 2, you get 2 pi on 2, which is pi. I am seeing a pattern. Okay, so how far do I need to go? Is that enough? So are you satisfied that we didn't do anything wrong, okay? These two different ways are going to give us the same set of solutions. Now you tell me, which do you prefer?
Oh,
Yeah, I prefer this one too, okay? We said not only does it have the advantage of you're solving one equation rather than two, but even the answer itself is more elegant, okay? It just catches them all. And you have to be careful when you're checking your answers and the answer you get disagrees with the answer that they give you. Here's what you do.
yeah, wrong.
Draw up your table of values, check them all out, right? Draw up their table of values and compare those, okay? Now, in this case, I reckon, now that you're sort of clued into it, if you looked at this and then you looked at these two, without generating the table of values, I think you might be able to see, yeah, I can sort of see that, you know, this is going to have more solutions to it. Every half a pi, I'm getting one. Whereas this, it's sort of like covering the gaps, okay? Other times, it's not so obvious. So here's what I'd like you to write down. This is the question I'd like you to do, which is actually question 32 in your set, but I want you all to do it now. It's sine 4x minus sine 2x equals 0. Sine 4x minus sine 2x equals 0. Has anyone done it yet? Question 32. Okay, that's fine. That's all right. That's great. I want you all to have a go at it. Come up with a solution, and then I want you to generate a table of values and compare it with the answer that they get. And in a few minutes, I'll show you how I do it, if we have time.